This is the third video covering the Unit 3 review packet. In this video, we will be going over topics 8 and 9. Complete the following proofs. For 38, we're going to prove the alternate interior angles theorem. Because I'm proving the alternate interior angles theorem, it means that I cannot use the alternate interior angles theorem in this proof. For our first statement, we have L is parallel to M, and that was given at the beginning of the problem. 2 is congruent to angle 6. I know that these two lines are parallel, so I'll just highlight my parallels and transversal. 2 is congruent to 6 because if you look at 2 and 6, they are corresponding. I'm going to mark these congruent. So my reason would be corresponding angles, and that is a postulate, cap. Next, we have angle 4 is congruent to angle 2. Again, I'm going to look at my picture. Angle 4 and angle 2 are vertical. That means they're congruent, and my justification would be vertical angle theorem. Finally, we have angle 4 is congruent to angle 6. If I look at my picture, I might say angle 4 and angle 6 are alternate interior. However, I'm not allowed to say alternate interior because that's the theorem I'm trying to prove. In general, a good strategy is look at your picture first. If something in the picture obviously tells you what the relationship is between two things, use it. If not, you go back to your proof and look at the previous statements. In the second line of the proof, I said that angle 2 was congruent to angle 6. And that 4 was congruent to 2. Another way of saying it is blue is congruent to pink and orange is congruent to pink, and because they're both congruent to the same thing, it means they have each other. 4 has to be congruent to 6, and that's what's happening here. They're saying 4 is congruent to 6. There's two possible justifications I could give. I could either say the substitution property of congruence or the transitive property of congruence. I'm a substitution guy, so I'm going to say substitution, which I'm going to abbreviate sub. 39. Given A is parallel to B and C is parallel to D. Prove angle 1 is congruent to angle 3. I'm not proving any particular theorem here, so I can use any of the things that we've learned so far this year. Vertical angles, same sides, alternates, anything I need to. First statement is our given, A parallel to B and C is parallel to D. Next we have 1 plus 2 equals 180. Looking at the picture, 1 plus 2, A. So I'll just cover this up because I won't need it. These are both inside the parallel lines, and they're on the same side of the transversal. Well, that means 1 and 2 are same side interior angles, and the relationship is supplementary. So we'll say same side interior angle theorem. Next up, we have 2 plus 3 equals 180. 2 and 3 share line D, and it's the same thing, same side interior angles theorem. The next line of my proof says that the measure of 1 plus the measure of 2 equals the measure of 2 plus the measure of 3. I don't think anything in this picture says this long and complicated thing. However, if I look at the previous statements, I can see that both 1 and 2 and 2 and 3 are both equal to 180. Since they're both equal to the same thing, they must be equal to each other. And that's what this does. So just like last time, where we had that same situation, we can either say substitution property of equality, or we can say the transitive property. I'll use substitution. Next, we have measure of angle 1 is equal to measure of angle 3. Looking at 1 and 3 in my picture, there's no transversal between them. So wherever I got this had to come from previous steps in the proof. If I look at the previous line, this looks very similar, just without the measure of angle 2. And because there's a measure of angle 2 on both sides, we probably just subtracted it off. The property that allows me to do that would be the subtraction property of equality, abbreviated SPOE. Finally, we have angle 1 is congruent to angle 3. Whenever we go from an angle measure to just an angle, and from equality to congruence, that's the definition of congruence. Congruence means that if the measures are equal, the angles are congruent. My last justification will be definition of congruence, which I abbreviate DEFCON. Number 40. Prove the converse of the same side interior angles theorem. I can't use the same side interior angles theorem for this proof because I'm trying to prove it. And what's more, because I'm trying to prove that L is parallel to M, it means that I can't use any of my regular or conditional parallel line theorems because I do not know that the lines are parallel. Given measure of angle 3 plus measure of angle 6 equals 180. Our next statement, 6 plus 7 is 180. Looking at my picture, 6 and 7 make a linear pair. Linear pair postulate. 3 plus 6 equals 6 plus 7. We've seen this a few times. Because these are both equal to the same, it means they have to be equal to each other. That was substitution or transitive. 7 equals 3. There's a 6 on both sides. We must have subtracted that 6 off. Subtraction property of equality. Here we have measure of angle 7 equals measure of angle 3. Oh, and then they're congruent. That's the definition of congruence. Finally, L is parallel to M. The only type of theorems or postulates that will let you show lines are parallel is a converse. So this has to be converse something. If we look at our picture, 3 and 7 are in the corresponding position. They're both in the bottom right. So that means this must be converse corresponding angles postulate. Moving on to topic 9. Find the slope of each segment in the graph. To find slope, we need to count the rise and the run. And we always start with the point first. So the first one says the slope of AB. Starting with the point on the left, I'll count the rise. That would be 1, 2, 3 down. And the run, which was also 3. As a fraction, this would be negative 3 over 3 or negative 1. CD. Down 2 over 3. Negative 2/3 does not simplify. EF, starting with my leftmost point, that would be down 1, 2, 3, and then over 3. Negative 1. Finally, GH, leftmost point, 1, 2, 3, and over 2. My slope here would be negative 3 over 2. Are any of the lines parallel? If so, name the parallel lines and justify your response. Parallel lines must have the same slope. Here, I have negative 1, negative 2/3, negative 1 again. These two must be parallel. So this would be AB and EF. Plot a point in the coordinate plane such that the line that goes through your points and x is parallel to GH. Parallel means same slope. So I just need to use the slope of GH, which was negative 3 over 2. I can either do that by going down 3 and over 2. That will put me off the graph, but that's okay. Or I can do the reverse, the over 2. I can go 2 to the left and up 3. Either of those would give me a line that's parallel to GH and goes through the point X. Determine if each pair of lines is parallel, perpendicular, intersecting, or coinciding. Justify your answer. For 47, both solved for y. Remember that slope-intercept form is when an equation is solved for y and is y equals mx plus b, where m is the slope. Because these are both solved for y, it means we have the slopes in front of x. One is 2/7, one is 7 over 2. Parallel lines are same slope. Perpendicular lines have opposite reciprocal slopes. Coinciding lines are parallel with the same intercept. Essentially, they're identical. These slopes are reciprocals, but they are not opposites. They're both positive. So these would just be intersecting lines. For 48, This has a slope of 1/3. This has a slope of 1/3. They are the same slope, so these are definitely parallel. However, we need to look at their intercepts to see if they're coinciding. Coinciding lines will also have the same intercept, which these don't. So these would be parallel. 49. Here we have a slope of -3/4. Here we have a slope of +4/3. Their slopes are opposite because one is negative and one is positive, and they're reciprocals. Because if I flip 4/3, that gives me, if I flip 3/4, that does give me 4/3. So these would be perpendicular. And number 50. These are not solved for y. So in order to get these to solve for y, I'm going to have to do a little bit of algebra with each one. For the first one, all I need to do to get y by subtract the x to the other side. If I subtract x, that would give me the equation y equals, and instead of writing 4 minus x, I always like to put my x first, so -x plus 4. For this equation, I'm going to need to divide by 2. When you divide an equation by 2, you have to divide every term by 2. So that's going to give me y, -2 divided by 2 would be -x, and then 8 divided by 2 would be 4. They both have the exact same slope of -1. However, because they also have the same y, the lines aren't parallel, they're actually coinciding. They're sitting on top of each other because they're the same line. '51 and 52. Write the equation of a line parallel to the given line. Parallel lines have the same slope. This has a slope of -4, so I need to write an equation with a slope of -4. For the y-intercept, I do not want coinciding lines, so I just need to pick any number except 2 for my y-intercept. For 52, it's already solved for y, so my slope is the coefficient of x. My equation for parallel has to have the same slope, so this would be 2/3 x, and now I just need to pick a different y-intercept. I can make my intercept 0, which is exactly what this is as it's written. So I'll just leave this as 2/3 x with a y-intercept of 0, and call. For for 53 and 54, we need to write the equation of a line perpendicular to the given line. Perpendicular means opposite reciprocal slopes. So I need to change the sign and flip it upside down. So the opposite reciprocal slope of this would be negative, because this is positive, and 3 flipped upside down would be 1/3. For the y-intercepts, on perpendicular lines, it doesn't matter if they're the same or not. So we can pick any number we want for the intercept. I'll just choose +5 because I can. And finally, 54. The opposite reciprocal, this one is positive, so the opposite would be negative, and if I flip this upside down, it would be -2. Y equals -2x, and again, I just need to pick a y-intercept. I'll pick 13, because why not? And this ends the Unit 3 review packet videos.